Hello, once again you are welcome to this YouTube channel aimed at giving you quality solutions to mathematics questions. My name is Jeffrey Giba, a third year mathematics student of KNUST. Today we are going to look at differentiation, one branch of calculus. And then our main focus today will be on the first principle. But before that, quickly, let's check on one rule of differentiation. And the rule states that you have a function in the form of ax to the power n. After differentiation, it should be n times ax raised to the power n minus 1. So you have a function to a power n, you multiply n by the coefficient, then you take 1 from the exponent n. So example, f of x is equal to x squared. F prime of x will be equal to 2 times the coefficient. A is what? 1. So 2 times 1 x raised to the power 2 minus 1, which is equal to 2x. So 2x becomes our f prime of x. So we are going to use the first principle to get this same answer, 2x. So in short, if you have to use the first principle, it means that we are restricted to use a particular rule. But other than that, we can go by this short method and have our answer. So the first principle states that the differential of a function is equal to the limit of the function f of x plus h minus f of x all over h as h approaches to 0, where f of x is our given function and f of x plus h is the function we get after we have substituted s plus h into our given function f of x. So here, from example 1, our f of x is equal to x squared. So we have to look for our x plus h. So f of x plus h is equal to x plus h all squared, which is equal to x plus h times x plus h. So we have x multiplying the whole function plus h multiplying the whole function. So x times x plus h times x plus h, which gives us x squared plus xh plus xh plus h squared. So now we add our like terms, which is xh and xh, which gives us x squared plus 2xh plus h squared. This is our f of x plus h. Now we have f of x plus h and we have f of x. So we have to substitute these two functions into our first principle, which gives us f prime of x is equal to limit as h approaches to 0. F of x plus h is x squared plus 2xh plus h squared minus f of x, which is x squared all over h. Now when we expand, x squared minus x squared will cancel out. So we are left with limit of h approaches to 0, 2xh plus h squared all on h. Now limit as h approaches 0. Here we have 2xh plus h squared all on h. When we separate this quotient, we will have 2xh divided by h plus h squared divided by h, which gives us 2x plus h as limit of the function whilst h approaches to 0. So whenever we see h, we put 0 there, but as h approaches to 0. So we now have limit as h approaches to 0, 2x plus 0, which gives us 2x. So by the first principle, we have shown that the differential of a function x squared is equal to 2x, just as we did by using the power rule at the first start. Thank you very much for watching this video. Subscribe to this YouTube channel, like the video, and hit the subscribe button. As we drop new videos, you will be aware and be blessed by them. Thank you. Have a nice day.